Hello, I'm Neil Kumar, Senior Product Manager at Ocient. Ocient is the next generation of data analytics platforms. Our flagship product, the Ocient Hyperscale Data Warehouse, uses a compute-adjacent storage architecture to outperform the competition for analyzing large, active datasets. Today, we're going to talk about OcientGeo and how it harnesses geospatial analytics at hyperscale. OcientGeo is a set of spatial database features within the Ocient Hyperscale Data Warehouse designed to scale and enhance the performance of spatiotemporal queries at massive scale. There are three key elements of OcientGeo. First, OcientGeo supports high-resolution geospatial types, supporting lines and polygons with up to 32 million embedded points. With up to 50x resolution of other spatial databases, Ocient doesn't require downsampling. This means geospatial data is easier to work with in Ocient and retains its value and accuracy. Next, Ocient has a unique geospatial index used to optimize performance for search and filtering of geographies. Unlike other spatial databases that leverage the H3 index to search and filter for objects on land, Ocient enables users to incorporate data from objects anywhere on the globe, including over land and sea, powering a broader set of use cases for business needs. Third, Ocient natively supports more than 120 geospatial functions. With this industry-leading library of functions, users can analyze spherical and spheroid models of the Earth with high precision and low latency at scale. Ocient's SQL capability allows for spatiotemporal analysis, in addition to native ETL and ELT, accelerated AI, and rapid iteration at scale. OcientGeo also leverages Ocient's open connectors, enabling users to leverage their favorite spatial mapping and visualization tools. So let's get to the demo. Imagine we are a large electric taxi vehicle manufacturer, which wants to understand where to place new charging stations. We'll leverage OcientGeo with vehicle telematics data to tackle this problem at scale. In addition to OcientGeo, this demo also visualizes the data through Metabase, one of the many integrations supported through our standard drivers and SQL. Before we look at the analysis, let's introduce the data. This dataset consists of 150 million simulated electric taxi trips based on real taxi trips published by the City of Chicago. This includes approximately 250 billion telemetric data points, leveraging the Ocient Geospatial Index. Alongside this telemetric data, we have second-by-second details on various metadata, such as battery level, range, charging station locations throughout Chicago, and details on each taxi. Let's break down the query and the powerful combination of OcientGeo functions that will run in seconds. First, we need to identify where taxis are located as they're running out of battery. Next, leveraging some OcientGeo native spatial functions, we'll see which of these taxis are far away from a charging station. Finally, now that we have a set of taxis that are low on battery and far away from a charging station, we can use more OcientGeo spatial functions to identify clusters of these taxis. Specifically, we can use a density-based scan with this function, stClusterDBScan. Now that we have a query that can help us identify locations where we may want to place a new charging station, let's run it. Here I have an instance of Metabase that is connected to an Ocient system with the telemetric dataset using our spatial index and the query ready. Again, this query is running on 250 billion geospatial points using a variety of OcientGeo functions. Using this button on the right side of the screen, I can run the query. And after doing a little bit of science, we can see the resulting polygons. By plotting these polygons on a map, we can see some zones where we may want to invest in new charging infrastructure. Thank you for watching this brief OcientGeo demonstration. Join our community on LinkedIn and request a demo at ocient.com to explore how Ocient can help you with your geospatial analytics at scale.